We're looking to make a building which in a sense is very advanced and right at the edge of what we can do globally in terms of these advanced systems for creating very high performance, very sustainable enclosures to our office buildings and our workspace buildings. But at the same time, we want to make a building that is truly unique, that really is saying something about this very special site in Sydney. This site on the bend on George Street is a very restricted site. It's it's very difficult to get a tower of a reasonable floor plate on this site. It has many restrictions apart from setbacks and definition to the street. There's an overshadowing plane to maintain winter sun access into Australia Square, and a whole range of complexities. So it became a little bit like a Rubik's Cube, and ultimately what you want to do is create a building which has an integrity to its form and doesn't look like it's simply the result of a whole lot of planning controls. So we developed two sort of semi-elliptical forms that sit, one facing north, one facing west, around an expressed core which is clad in terracotta. So these rise up from George Street and create these two primary orientations. In that way, we were able to deliver the best natural light and view to the interiors and structure the workspace in a way that was going to create a very flexible contemporary work environment.
Our involvement started off with a question of can we do it, and after that it became a race around the world to bring together the concept, the solution, the materials, the technology. And I guess we said yes in that first instance because we understood that within the group we had certain technologies that we could bring to play on this building.
Somfy partnered with Permasteelisa to deliver the facade on this project. Our involvement has been around supplying the motors, the control system, and install and commissioning of the control system on the building.
You know, I think there are too many grey, bland office buildings in our cities. They tend to be characterised by high performance tinted glazing, which makes them very black. You can't really see into the buildings at all. Grey aluminium. And the buildings kind of look anonymous, and they almost look like people wearing sunglasses. So we wanted to make a very different type of building, and we're very interested in using natural materials, materials that have a warmth and a patina to them, that age well and that have this sense of the natural world as well. So we had this concept of making a tower of wood, of wood louvers. And to have a building appear that way, you really need to put up the wood on the outside, which of course is extremely difficult to do, or you need to sheet the building in a really clear sheet of glass and have the wood louvers tightly behind that. And then have the performance glazing behind that. So you get a multi-layered facade system. And that is the closed cavity facade system that has been used at 200 George Street, a system that has not been used in Australia before now, but that in terms of wood being in the closed cavity, it's the first time in the world that has been done to my knowledge. And that then gives the result of a building that not only changes subtly with the position of the sun, but a building that appears to be made out of wood. We've worked with the industry on pretty sophisticated facade systems for some time now. I think that all good outcomes are partnerships with the industry. You know, there's enormous expertise there and it's changing all the time. So as designers, we always engage with the industry very early, often in the conceptual stage of design competitions. And in this instance, we got some input from Permasteelisa, who we've worked with before on several of our buildings.
We understood that we could eventually incorporate the timber facade or the timber lamellas as envisaged by Richard. The closed cavity facade is a technology that is being well researched by Permasteelisa. We've created the ability to pump a small amount of dehumidified air. The purpose of that is to keep the dew point at a certain point where condensation won't occur within the cavity. The air is pumped from a central blower on the building, so it's one unit. It's not a massive machine, but it's enough to run a 30-odd storey building with some 3,000 panels. When they said to us to use timber, we started to look around what was available. We searched our backyard, we went through the Australian timbers, we looked overseas, asked a lot of questions, eliminated a lot of species of timber, and eventually we started to eliminate treatments of timber. So we settled on a timber called Accoya. It's chemically treated. It changes it at the granular level of the timber itself. We change the structure of the timber. So we did UV testing, we did stability testing, we looked at how the timber was cut out of the logs themselves. We've given the building the ability to understand historically the weather conditions as they occur seasonally.
To deal with the different issues of orientation and heat load, when you match those to a desire for view and natural light and glare control, my own view is at the moment you need an active system. You need a kinetic facade that's going to respond automatically to these variables. So a mechanical system like that, located with motors on the outside of the unit so they can be accessible and so on, is integral to a success. Partnering with industry is really key, and Somfy are involved in this automated system, so their involvement again was pivotal to the success of this facade system.
The project's got a number of technologies that allow the blinds to operate. The first of those is sun tracking. So as the sun moves through the sky, it's at different angles on different days of the year, and the blades will actually move through a series of positions to make sure that the right solar loading is on the building, so it's protecting the building, and also letting a certain amount of light through into the floor plate without having glare for the people actually within the building. The second part is shadow management, and the